this particular lecture, I am going to introduce you to the concept of thermostructural analysis. So, why thermal structural analysis or coupled analysis is essential? So, what happens in many products where they are inherently subjected to different temperatures, which cause a lot of unwanted structural stresses, and this is going to influence the structural behavior or performance of the product. So, for example, see here is an electronic where it is going to get heated up, and this particular heat is being transferred to this side wall, and what is happening, there are thermal stresses that are occurring inside this side wall. So what happens, in order to study such sort of phenomena, we need to perform coupled analysis, and in this particular case we should be performing thermostructural coupled analysis or thermal structural coupled analysis. In order to study the performance of a product under all kinds of thermal loads as well as the structural loads, we need to perform this thermostructural coupled analysis. Then, what do you mean by coupled field analysis? A coupled field analysis is a combination of analysis from different engineering disciplines. It may be from, say, structural to dynamic, or otherwise say thermal to structural, or structural to CFD, or CFD to structural. If we are going to combine analysis from different fields, we can call it as a coupled field analysis. So here, coming to the thermal stress problems, there are two types of coupling. Loose coupling. So loose coupling means what happens? Temperature distribution from the thermal analysis induces thermal strains inside structural analysis. So what happens, due to the temperature distribution inside the body, which is calculated from the thermal analysis, this particular thermal strains are taken as an input into structural analysis. Often deformation rarely influences the temperature distribution, and this is referred to as one-way coupling. And then in mechanical, the temperatures resulting from the thermal analysis are mapped onto the structural analysis as a thermal load, and in this type of coupling, one-way or weakly coupled system, the thermal analysis is going to be done first, and then it is followed by the structural analysis. As I've told you, whatever the results that we come across from this thermal analysis, we are going to take it as an input for this structural analysis. Then coming to fully coupled analysis or strong analysis, we have a direct coupling between both of this particular system, and if you want to perform this type of strong coupling or fully coupled analysis, you need to have what is known as an ACT system. You need to give out commands in the command objects. Then thermomechanical analysis. So method 1, load transfer, and method 2, direct coupled field analysis. So coming to the method 1, load transfer, structural and thermal physics are solved sequentially. So what happens, first we are going to solve the structural problem, then we are going to deliver it to the thermal system, and then once we solve the thermal system, then we are going to get those results back onto this structural system as shown here. See here, 2 or more analyses are coupled by analyzing results from one analysis as a loads to another, and we should be using separate models and meshes if possible. Then coming to the method 2, which is a direct coupled field analysis, structural and thermal physics are solved simultaneously in a single analysis, and we are going to use the single model and mesh and set of results. This particular technology is going to be achieved by the use of a coupled field element, and if you want to have access to coupled field element, you need to be having ACT, or otherwise you need to be modeling this particular element through the commands that are available inside Ansys workbench. So coming to the applications of coupled field analysis, you can apply all these type of analysis to all aerospace, automobile, electronics, sports, and other sorts of offshore structure industries. All the fields where temperatures is important factor along with the structural loads, this type of coupled field analysis is important and always applied and always performed. In the next lecture, you are going to see how to perform a thermostructural analysis on a heat sink using Ansys workbench. Thank you.